Children, in the last turn, we had discussed about Cartesian product and that whole exercise on Cartesian product. And now we are moving on to relations. Okay. So as they have defined here, that definition 2 given to you, a relation R from a non-empty set A to a non-empty set B is a subset of Cartesian product A cross B. So A cross B, we have seen how to find that for two non-empty sets. And now any subset of that. So A cross B is also a set only. That is what we had seen in the last term. So subset of A cross B. Various subsets of A cross B would be termed as a relation provided the subset is derived by describing a relationship between the first element and the second element. So we know we get ordered pairs in A cross B. So if there is a certain relation between each ordered pair present in that particular set, then that is termed as a particular relation. Okay. The second element is said to be image of the first one. Like one example I had solved today, there was this question where two ordered pairs were given and then B was 3A minus something. It was like that. Okay. So when there is a relationship between X and Y of that ordered pair, then that is termed as that subset collection of those such ordered pair is said to be a relation. Okay, so that will be more clear, and we'll first go through these various definitions. Now next one is the set of all first elements of the ordered pair. All x's if you keep collecting from the ordered pair, then that is said to be domain of the relation R. And obviously A cross B hai, तो आपके जो first elements होंगे they will be from set A. Okay, so your domain would comprise of set A, right? Next definition, the set of all second elements. Second elements will be drawn from set B. We know in A cross B, if it is a subset of A cross B, we know all entries or y's of the ordered pair will be from set B. Okay, so they are saying the set of all second elements in a relation from a set A to set B. When I say a relation from a set A to set B, means R will be subset of A cross B. The Cartesian product of A cross B has to be considered, is called the range of that particular relation. And quite obvious, the whole set B is said to be the codomain. Agar A cross B hai, हमारा Cartesian product, so B becomes our codomain, A is our domain, and from the codomain, certain y's can be the images of our elements of domain, and collection of all those images they have termed as range. Okay, so quite obvious that range will be a subset of codomain. Okay, so if you observe through examples, things will become more clear. Okay, let's read more. Then a remark out here given, a relation may be represented algebraically either in the roster or set builder form, because it's a set. Basically, we know for set we have two types of representation: roster where we list or tabulate the elements, and set builder when we define the relationship between the elements. Okay, so likewise, a relationship can also be represented in roster as well as set builder form. Okay, or maybe through an arrow diagram as they've shown you above. Clearly here, this is an arrow diagram for a relationship where this P is our domain having elements. This is how we show the elements. This is diagrammatic or Venn diagram sort representation of set P, our domain having entries A, B, and C. Set Q out here is a codomain. And codomain has entries as say Ali, Bhanu, Binoy, Chandra, and Divya. Okay, and then these elements of domain, A is mapped with, we say that mapped with or is in relation with Ali. B has relation with Bhanu and Binoy as well. Okay, and C has a relation with Chandra, and Divya is alone out here. Okay, so we can have extra entries in codomain. So domain will be, if I say find the domain of this relation, your domain would be A, comma B, comma C. Set P, D. Domain of relation would be A, comma B, comma C, and codomain would be Ali, Bhanu, Binoy, Chandra, Divya. and range will be Ali, Bhanu, Binoy, Chandra, only the elements that have been mapped. We'll drop out Divya from there. Okay, so that is how it is. So this is called through arrow diagram representing a relation. So that is what they were telling you out here. We can represent visually, a visual representation or diagrammatic representation of relation is through that arrow diagram. Now there are certain examples here, children, which you will read through on your own. They are simple examples, and try to understand. If there's any problem, let me know. Then in the next go, we will discuss 2.2.